All right, thank you. Glad to be back here. This is actually my third time at IglooConf, which really is the coolest cloud conference in the world. It's freezing here. It's freezing here, literally, actually. So I was telling you the other day that the rain here seems to be broken and it's frozen. And it's from Seattle, we're not used to this. So my talk today is about messaging and serverless and kind of the future of what we're doing with that at Microsoft. Some of this will be about products that I'm involved with. Some of it will just be a little bit of speculation. Do remind yourselves and be aware of, I am the last thing standing between you and the weekend. And a beer probably, and you are definitely the last thing standing between me and a beer. So let's try to make that work. Who am I and why am I here? By the way, I know audiences here aren't always the most interactive, but the more interactive you are, the faster this will go. The faster I will go through it. I can slow down as much as I want here. So I'm a group principal program management manager for Microsoft. Say that 3 times fast, that's great. And I'm responsible for the messaging services in Azure. These are the 4 primary services I'm responsible for: Event Hubs, Service Bus, Event Grid, and Relay or Hybrid Connections. Anyone in this room using any of those? Hands up, yes. Yay, more, okay. So yes, if you have questions, wait to the end if you can. I will stay around for a little while. May as well talk to me while I'm here. This is pretty far away from me from home. I've been working in distributed computing a pretty long time, longer than I actually would like to think about. And today is my 1719th day at Microsoft. So before this, I had a real job. Yes. For those of you that don't count your lives in days, and I am nearly 15,000 days old, that's just under 5 years that I've been at Microsoft. So that's my Twitter handle. You can get a hold of me through there. I am here to entertain and surprise and delight you, and maybe scare you a little bit too. So with that, let's get started. I'm hoping to at least surprise or shock you 3 times during this presentation. So the first one is this. I love Finland. I was going to wear this, but I was advised as a foreigner never to enter Finland in the winter, especially wearing red and especially coming from the east. So I didn't, for safety reasons. Too soon? Sorry. So this is what my home looked like the day I left, which makes me laugh. It was 12 degrees, your degrees, not our degrees, not American degrees. So quite warm and nice, and it's not like this here. So that is what I get to go home to. So hence I want to get this going. So what is serverless? There have been some really good talks the last 2 days. I actually missed my sessions coming to the sessions yesterday because of the weather. So my flights were canceled. What is serverless? You have some view over what serverless is after the last few days, and kind of this is almost like a religious question to a lot of people. You get a lot of different answers. Ask 5 people and you'll get 7 different answers. So there are servers in it, yes, no, maybe. There's Jeff. Yes, and it's true. There are servers somewhere, but that's the whole idea of serverless, is you're not supposed to think about them. So we're going to digress a few times during this talk, and this will be our first digression. Mushin. Anyone familiar with the term of Mushin? No mind, yes. So this is a Zen concept. It's big in martial arts, especially Japanese martial arts, and it's of no-mindedness. Now that doesn't mean you're like brain dead or really hungover or something. It means that you're prepared for anything by not thinking about any one particular thing. So you're just in a state of preparedness. This is important for martial artists because you're usually fighting someone, and if you're thinking, well, I'm afraid to get punched, or this is what I'm going to do, the moment you have a plan, it falls apart in action. So Mushin, this concept, no mind. So mindlessness. What does Mushin have to do with serverless? A little bit. This is me at work one day. That was Halloween. I do kendo. That's why I brought Mushin into this. When you're looking at what is serverless, the idea here is you have no concern for these things. It's not FAS. Functions as a service or functions or Lambda or any of those things aren't all of serverless. Serverless is the idea of not having servers, of not having operating systems, of not managing or concerning yourself about capacity or underlying components. So this is the mindset and the frame of mind you're in. Serverless Zen. So think about that. And this is my bold statement, my first bold statement for today. Serverless is a description of your technical user experience or your architecture. It is not a description of a pricing model. So marketing people, they love latching onto something. And so you'll see a lot of people say pay-as-you-go or pay per execution is serverless. And I don't personally believe that. I think that's a pricing model that has nothing to do with the architecture. I know we're all cost conscious about what we're spending, but when you're building something, are you picking the components based on what their billing models are? I mean, you might be if in certain circumstances, it's always a consideration, but it's not where you start. You're not going to pick to build things just because of what they cost. So getting back to that pay-as-you-go, and I would challenge a few people in this room, where's Chris? There he is, on this one, is when people say pay-as-you-go, what is go? What does that mean? Is it CPU time? And if that's the case, it's just time. So saying pay per execution is not paying for time is kind of twisting the truth there. Is it paying for memory and resources? So what is it? Is it, if you look at a lot of serverless platforms, they charge by CPU gigabytes. So it's memory and CPU kind of combined together. Yeah, that's why marketing people love it. They just make it up and be like, yes, this is the thing. So now I want to do a very brief look at event hubs and functions together. I'm hoping everyone knows a little bit about what event hubs is, but we'll explore it while we go through here. And real quick, what are these things? So these are literally copied right out of our documentation pages, I think. Event hubs is a big data streaming platform, an event ingestion source. So it's basically a buffer. It's like a distributed log. Functions. What is Azure Functions? It's a serverless platform. So it's a environment to give you on-demand code execution. FizzBuzz. Does anyone know FizzBuzz? This one's kind of popular in the States. It's a programming challenge to give people so you know that they actually know how to write some code when you hire them. So my last company did this one a lot. Basically, you ask them to write a program that prints numbers 1 to 100, and for multiples of 3, print the word fizz. For multiples of 5, print the word buzz. And for numbers that are both multiples of 3 and 5, print FizzBuzz. Otherwise, just print the number. So this is kind of just does this person actually know how to write any code at all? It's not, is this a good programmer? It's kind of shaking out people who maybe didn't study computer science at all or don't know how to write code, but ended up in an interview with you, which does happen. So I'm going to show you this real quick. In Azure, in functions, which will be the worst functions demo you've ever seen in your life. So I will just do this through the portal because I like the portal. And I'm going to go into an existing function app I have. I'm going to add a event hub trigger. Yeah, give it a name. I think the name of this event hub is FizzBuzz. I pre-made some of this just in to be conscious of time. But I will start the function from scratch. And I'm going to just paste in what I want this to actually do. So this is the reason you give people FizzBuzz, is because it's that easy. It's just a few lines of code. You're literally just saying, hey, if this is divisible, modulo 3, modulo 5, or both. And now I'm going to save this, open up the logs for it, and I have, let's see, did that work? I think so. I have a few Visual Studio projects we'll run through. I never do live demos, so this is an exception for me. Hopefully this one will go well, I'm pretty sure. The other ones we'll see. So here I have just a simple .NET Core console application that's just sending these numbers. It's doing the count instead of putting the for loop in the function. I'm just going to run this. I'm going to feed this. It'll run, send some messages, and I'm going to go look at the console output here in the function log. And see, this is perfect. I couldn't have planned this better. So this did work, right? It's actually printing the right things. You can see it's sometimes printing fizz. It's sometimes printing buzz. It's sometimes printing both. But this is really interesting. The last one is the number 1. So this is a good point of when you get to serverless and messaging and how these things collide. Is what I have here is I have a stream, and you can see that what this function's doing is it's doing one function execution for every message in that stream. But that stream has multiple partitions because Event Hubs is a partition log, like Apache Kafka. Anyone familiar with Kafka? Apache Kafka, heard of it, using it? Yeah. You will be familiar with it in the future, most likely, but it's more of an infrastructure service, so you won't hopefully ever have to run it yourselves. So this is funny because this tells me something's going on that doesn't make a lot of sense. I can fix this. Let's see how I walk us through this. So it works. So what makes this serverless? There are no servers here, right? I didn't have to deal with any servers. Yeah, sorry, Jeff. We know there's servers there, but I'm not managing them. It does scale automatically, so there is a good scale story here, and all the underlying infrastructure is taken care of. But it's not totally perfect. Like you could see by that one being there that there's something a little bit off here. So there's a few things going on that we want to look at. The first is what's really happening is I have my laptop here. It's sending some information up to Azure, up to an event hub, which is in North Europe, and then that is being read by a function. This is a nice marketing diagram. It is not a really good reflection of reality. A better reflection of reality looks a bit like this. I have my computer, it's talking to an event hub. That event hub has partitions in it, because it's a partitioned log. That's like the definition of a partition log. Each of those partitions has some subset of data in them. And then there's readers for that event hub connecting through a consumer group. And there is a server hosting this stuff, and that's your function, being hosted in a server there somewhere. So this is a more concrete view of what's happening. And you can see, at the very least, you can see that since I have two partitions, I'm not going to have my stuff in order. The data is going to be everywhere. So this is kind of a first complication. So where does this break down? A few places. One, the order thing, yeah, that's interesting. You can get past that. But there is an inherent scale limit here. So there's an inherent limit in parallelism. And it's the result of the partition consumer model, so of the partition concept. So this scale limit has nothing to do with functions. It has nothing to do with whatever is reading from the stream. And this is just part of how things like event hubs and Kafka work. You have those partitions, you have your function reading. Functions does a lot of stuff for you, so it's hosting this compute somewhere. Everything's honky-dory. It's actually looking at how much traffic you're using and how much resources you're using. And when you use a lot, it will actually scale and put those instances of that function on different machines. So now you're scaled out to multiple machines. But the nature of a stream is such, of a partition log, is such that you have one reader per partition. So the maximum number of servers that functions can put on this application is the number of partitions in the event hub, and that's 4. So eventually, 4 is your limit. You could say, hey, just let me add partitions to my event hub. We are going to do that at some point, but that's not really the answer to this. It depends what kind of problem you're trying to solve. So functions does scale automagically. Everyone loves automagic scale, right? Yeah, things that just kind of happen, but only up to that point. And that's kind of, that sometimes you'll hear softies, Microsofties, talk about this concept that came from SQL called maximum degree of parallelism. So max stop, that's the upper bound of your limit on scale on this. You can make those things go pretty fast, but the ultimate limit is the max stop. So before I get to that, why is a queue better? I do want to show you how you can actually make this be a little bit more sane. And I have it right here, is that when you're sending to an event hub, when you send data to an event hub, you have some options. You can send the data and you can send a partition key. A partition key is just a value that's going to make sure that data stays in a partition. So it's a key for that partition. In this case, it's going to be a hash of the word or the string that I pass in. And now all this data will go to one place. And if I run this function again, and I go back and look at this console output, now the numbers will be more in order because they're actually executing on one host and only in one partition. So there's not 2 instances of the readers because there's 2 partitions. This way, one of them's not getting data, one of them is. And now you can see, I've hit my log threshold output. But you can see as I count back that they are in order this time. So it's not the chaos that it was before. But that would mean limiting your degree of parallelism to 1, which is probably not what you want to do. So how can queues actually solve this problem better? We talk about this sort of parallelism piece. When you look at a competing consumer, so a queue is a competing consumer, not a partition consumer. The kind of the easiest way to describe that sometimes might be that a log, like an event hub, it's a client-side cursor. So when you connect, you have to say where in the log you want to connect, and then you read forward. A queue is a server-side cursor. You just say, give me the next message, and it's just going to show up. And I'm not saying like a service bus queue or a storage queue. I'm saying the concept of a queue. It can be any other queue. It could be IBM MQ. It could be Amazon SQS. It doesn't matter. And why that's interesting is because sometimes competing consumer is actually good. Because if you want to have thousands of machines running these tasks in parallel, then you can, because they're all just pulling from one centralized queue. You don't need thousands of partitions. And when you kind of get to that point, think about if you're saying to yourself, I'm using Event Hubs for some reason, maybe because it's cheap, maybe you decided to use it because it's very cheap, you're already making a mistake, because what you want is not 1,000 partitions. You just want an ability to scale out, in a different fashion. And it has nothing to do with what's faster. It has as a service. It has to do with what's faster for your use. So this is kind of an important thing to think about. And another important thing is that a queue treats failures differently. So in a log, you're reading that log, there's a reader for that partition in that log, and at some location in that stream, you hit a failure. Well, what do? Do you stop? Can you keep going? Like in a queue, a failure happens and the message just ends up back in the queue. So someone else will try. But in a log, you have different semantics, so it can be a bit more of a challenge. So that was first demo. That was the most inefficient use of Azure you've ever seen, I think. Sending one float number messages or integer messages over Event Hubs. Now we're going to take a very brief detour. Does anyone here work in the financial services industry? Trading companies, banks, anything like that? Okay, then this might be more fun if you don't. I have a present for you. You're going to learn a little bit about investing in finance. Does anyone here actively manage their retirement or stock portfolio or anything like that? Okay, cool. So there are two popular ways to do that. One is fundamental analysis. So you're looking at a company, its balance sheet, the management team, all their product pipeline, all these things, that you're analyzing the fundamentals of a company. This is the kind of stuff Warren Buffett does, and he's very good at it. The other is technical analysis. Technical analysis is what we're going to talk about now for a little bit, and streaming. So before that, my first present to you is the greatest advice you'll ever hear in investing. Buy low, sell high, right? That's the idea. That's what everyone wants to do. So thinking about what a stock ticker is, I like using the analogies from financial services, from stocks and from equities in particular, because I worked in that industry, and because who hasn't seen a ticker on the bottom of the TV and these prices going by? And this is kind of why people actually care about this. So the stock ticker is just the feed. It's a feed of prices that are changing over time, whether that time is days, seconds, hours, whatever it is. So kind of the normal definition is what's the daily close price for a single stock. So here's a simple chart of Microsoft from yesterday. I was thinking about doing this interactively, but I think it's easier to show it here. So these are the prices, closing prices. The line is a chart of the closing prices every single day. The bottom, we don't need to care about so much yet, and this is the last year. If I look at this, or last 6 months, if I want to do some signal processing on this, right, I'm trying to figure out where to buy and sell, right? I'm trying to make money. I don't want to buy here. That would have been a mistake. I'd like to maybe buy here, maybe here. Oh, that looks like a good opportunity. So how do you do this, right? So a very popular way in the technical analysis community is to do signal processing. And if anyone has an electrical engineering degree or something like that, you'll know a little bit about signal processing or a good statistics background. So a moving average is probably the simplest way to explain this, and it's what shows you what's different between a stream and a queue. So a moving average is you're taking a set of prices, so maybe the last five prices, and what you're doing is you're really creating a filter. You're creating a filter to try to make the chaos that is that chart have some sense behind it. So you're doing a rolling average, basically, is what a moving average is. And this is a chart of Microsoft stock with a 5 period, so 5-day moving average running on it. So the 5 days pretty close. You can see kind of it's tracing it very much. It's just a little bit behind. You can see the line actually happens a little bit behind the price. But it's a filter, so it eliminates the noise, so you don't see as much chop in this. And if I put on another moving average, which is a 15-day moving average or a 13-day moving average, then you can see it's this one's even further behind. But what this means is that these are filters that are slowing down the movement of the chaos in the signal. So this is signal processing. All DSPs and a lot of audio stuff, a lot of video stuff do this sort of work. Now what's interesting here is if you look at this is actually a trading strategy from technical analysis, and it's a very basic, primitive one, is to look for when two moving averages that have different time periods cross each other. So you could see when the faster one crosses the slower one, it's a sign that the stock is actually going up now. And when the faster one goes below the slower one, it's a sign that the stock is going down. So looking at this at the red and green points, you can see the green points would be good times to buy, and the red points would be good times to sell, or if you really have an addiction to risk, to short a stock, so like to sell something you don't actually own. So this is signal processing. This requires things to be in order. So this requires a stream. That's the nature of this type of work. If the prices aren't in order, you're not processing the signal correctly. Did anyone notice anything about those numbers, 5 and 13? Anyone? And they are Fibonacci numbers. So Fibonacci numbers are very big in technical analysis. This type of stuff is crazy. You can lose your mind in it. So let's real quick look at what a moving average crossover processor would look like. So I'm going to go kill this application, which is done, and go into a different Visual Studio. I can kill this, so clean up. All right. So the sending for this is going to look the exact same. I'm just going to send some data. It's pretty easy. I'm actually making fake prices here because I don't have a license to good data feed right now. So in Event Hubs, I'm going to create an event processor host, a stream processor. So this isn't something that's randomly going to get one point. It's something that's going to always run on that one partition. Behind the scenes, Functions is hosting this exact component for you, this event processor host component. It's a cool agent because it works in all our major languages, and all you do is you point it at your stream. When you instantiate an instance of it, it looks at that event hub, sees how many partitions there are, and then creates a reader for each partition. And then if you instantiate another instance on another server, they're using leases on storage basically to divvy up the workload between multiple servers. So it's like a peer-to-peer sort of scaling model that works for you. And this is part of how Functions is able to auto-scale for you. They do a lot of other stuff too. But in this case, what I'm going to do is I'm going to make a moving average processor. Behind the scenes, Functions is hosting this thing, event processor host, and the way it works is there's an interface that you implement. It's got 4 methods: close, open, process errors, and process events. I'm guessing you can probably guess what all of those are. And this is how simple moving average processing is. All I'm going to do is go look at the moving average. I'm going to take the feed itself, like a memory buffer of prices, and how long I want that average for. And then I'm going to take the previous day's moving average. I'm going to add a new price, and then I'm going to take the next day's moving average. So this is a pretty cool way to look at this and to kind of play with these sorts of things. So if I run this, super simple. It's just going to run through here and do the same sort of thing, and it's going to print out. I don't know, well, since I'm using random numbers, I don't know if it'll actually hit a buy or sell point. But when it does, it'll just print out the action, which is to buy or sell something. So that's kind of the idea here. And this is, again, so like this is something that's a bit different than we were doing in Functions. FizzBuzz is useful in the Functions model because the output of the function is really only dependent on the inputs to that instance of the function, that execution of the function. This is something where you have other further dependencies. So you could say, well, why don't I just use something to hold that stuff in a store when I'm doing like a moving average pricing and host this in Functions? You could, but now it's becoming a lot less serverless, and you're actually building something stateful and serverful. So that's probably not kind of the model you want to approach for this sort of stuff. So let's see. So why won't this work in Functions, right? It won't. You can try this in Functions and it probably won't work. And it's easy reasons to see why it's not going to work are this. It's because I'm actually adding prices to this collection that's a memory resident collection in this process, and then I'm dropping them off so I don't run out of memory. So in Functions, you can't persist data between the executions of that function. So that's exactly why this isn't going to work. So that's kind of your biggest thing. On technical analysis, if you're interested in it, it's a cool area. People, some of the best paid people in Chicago and on Wall Street are the quantitative analysts who do this kind of work. It's cool, but be aware, like you can lose your mind doing this stuff. So now I want to show a practical example, I guess, before I get there. So what would be a good way to host something without having to be serverless? Take this code I just wrote and host it somewhere that's not on my machine would be ACI, Azure Container Instances. And so is anyone using ACI yet or playing around with ACI yet? Is anyone using the Cloud Shell? Like either the PowerShell or the CLI in the Azure portal? That's ACI too. So that's actually where it started. So more people are using ACI than they realize. What's cool about ACI is I can take the code I just wrote and I can make it a container and I can go run it in Azure without having to create a VM to do that. And to show you how powerful this is and how very without a VM this is, I'm going to do something I never do, which is a fully live demo of stuff that's not even built right now. So let's do this. So if we look at something like my stream, my stock price stream, stream's cool. I like having the stream somewhere. A lot of people want to have data in more than one place, right? Or you want to copy your data between places. Apache Kafka has a concept, a tool called Mirrormaker. Mirrormaker is what we're going to walk through right now. Mirrormaker is just a executable you run, and you have it running on one cluster of Kafka, which you could think about as event hubs, and or near that one cluster. And all it does is it reads from one data center and writes to another data center. So it's just reading and copying the data, but you don't really have to do anything. It's a program that's already written, ships with Kafka. It's really useful for DR scenarios, like if you want to copy your data between specific topics or event hubs between between regions. It's also useful for hybrid scenarios. If you have a stream of data on-prem, like in a factory or something, and you want to take that stream and then copy it up into a cloud environment or consolidate them from many on-prem environments. So walking through this, let's cross our fingers and see if all this is going to work. So I'm going to do a few things here. The first commands I'm going to type in, I'll give us a little bit more room. The first commands I'm going to type in are just going to create a resource group, is the first one. I'm using some random numbers here so none of these things collide with each other. And now I'm just creating two variables for source and destination name. So I've assigned those. Now I'm going to create an event hub. This is going to be my source event hub. I'm creating this in North Europe, and I'm using a feature flag for our CLI for event hubs, which is enable Kafka set to true. So when you create a namespace for event hubs, you decide at creation time if you want to enable Kafka on that namespace. And if you do, then what we do is we speak two communication protocols. So we can speak the native Kafka protocols if you or your partners or someone are using that, and we use our normal protocol, which is AMQP. So we're not actually hosting Kafka, but it is at a wire level compatible. So that first event hub is created. This is good news. That worked. I'm not too worried about these pieces as much as the others. If creating an event hub doesn't work, I think I have bigger problems to deal with. So now I'm going to create a destination event hub. I'm putting this one in North Europe too, but I guess I could put it in West Europe. I should. It's probably more interesting if I do that. So while I'm creating this event hub, I'm going to go copy my next command, which is where the things will start to get a little bit more interesting. And I'll just walk through some of the features that are in here that I think is part of what makes this sort of stuff serverless. There is a feature on event hubs called auto-inflate. Auto-inflate, when you buy event hubs, you're basically paying for a megabyte per second. And you can have many megabytes, but you pay multiples of this amount. And so this auto-inflate feature is something that will look at your stream live, and if you're hitting that limit of what you've purchased, it's a policy setting that'll grow you 1 megabyte at a second. So like if you normally run pretty low level throughput, half a megabyte, and like Friday afternoons, you get a big spike in traffic. No one has to go in there and change it. It'll kick up automatically so you don't have any slowdowns or problems. So I've got my second namespace, and now what I'm doing is I'm just using CLI to pull the connection strings out of these, so I don't have to show them to you, and so I don't have to copy and paste them. I think the other things I wanted to point out that are on here are that my capacity right now, so I do have one throughput unit on this. That means it'll do 1 megabyte per second. I can see my tier, and I can see a couple other pieces of information that are a little bit interesting. The next commands, now that I have those, I'm going to go create 2 containers. So I'm going to use ACI right now, and this will take just a little bit of time and create the first container. And what this is doing, this is part of why I think ACI is really cool too. This is slick. I'll walk you through. This is fun. So some of these things are normal Azure things you're going to see. I'm giving it a name. I'm giving it a region. I'm actually giving it a container image. And this is cool because I'm just using the public Docker image list. And I'm pulling the Confluent image out of here. I'm not building a container. I haven't built a container. What I've done is I've told ACI, go use this container that's in a public list of containers anyway. I can do it from my own private list of containers using the container registry service, or I can use it from here. The cool thing on this is what I'm doing is I'm then telling it to go mount this GitHub repo as a share in that container. It's a Linux container. And then this GitHub repo has some, I'm telling it where to mount it, and then I'm telling it what command to run when this container starts. So again, this isn't my container. I didn't build this. This is from Confluent, which is a company that works on Kafka. And what this is going to do is go take their container, spin up an instance of it, which is done now. And now I'll start the second one. And run that container in Azure and run this code that's on here. So real quick, just so we can see what the code looks like, I'll go take us to look at that. Oh, the mount path isn't a piece of that, but that's okay. Here we go. Okay, so all that's in here, so you can see there's no like crazy magic or anything. I have 2 shell scripts, and that's it. So they're pretty small. One of them starts Mirrormaker. You can see what it's doing. It's when it starts, I've passed in those things, the connection strings as environment variables. So the container is stateless. Everyone in here using containers in some sort of way, or played with containers ever? Yes, no? I know you're tired, come on, hands up. Yep, all right. As an American, I probably shouldn't say that, hands up, but that's okay. So all this does is at runtime, I'm injecting some environment variables, which are things like the connection string and the credentials for this event hub. And this is the script that starts at runtime. You saw that in my CLI here. You can see I'm saying, hey, run this exact script, so run this exact command when this thing starts up. And now if I minimize this window and actually go look at my resource groups, I should have a Mirrormaker one, MMRG with a random number. Yes, okay. I'll see my resources inside of here. And I can see I've got 2 event hubs and I've got 2 container instances. If I go look at one of them, so I'll go look at this one. This is a container that's actually running Mirrormaker. And if I go look at the containers in this instance, in this container group is what it's called. It's basically like a VM behind the scenes, but you'll see that I didn't have to create a VM. I can see some cool things here. I can see the properties. I can see the logs, which I can look at right now. And I can actually connect to this running container through SSH and run like its own. It's like having CLI or Cloud Shell just into that one container. So this is pretty cool. You can see the state of this is running. This is a container that will always keep running. And the command that I created it with would show that I didn't tell it to ever stop or to stop running. The second container is created now, which means that now we're going to get some cool stuff out of this demo. So, and how you control those like lifecycle events was in one of these previous commands when I created the first container. Let's go see. Yes, which is here I'm giving it a command line and I'm telling it a restart policy, which means restart if it fails. You can also say restart never. You can do things like that. So I'm just telling this thing what I want it to do. It is done, and now we can go play with these. And what I should see if my demo has actually worked. And yes, so I see the logs from this. It's giving me a little warning, not an error warning. I'm expecting that. And so this other container, this load generator container, what it does is load gen is a tool that comes with Kafka. It's just another shell script. It just makes fake traffic. And you can see this thing used a bunch of CPU for a little while. I don't know why the chart says 140%. I'm pretty sure it didn't actually use 140%. But if I go look at the container itself, I can see its history and I can see its logs. And what I'll see from here is that it actually ran the Mirrormaker, the load generator script that ships with Kafka. I'm not actually running Kafka. And if this portal actually shows this to me, I'll see that it wrote out I can see the records. So I can see it wrote out so many records, and it's giving me the average latency on them. And what I'll go see now is if I go back and look at my event hubs, so I have source and destination event hubs, it's been long enough now that I should actually see the traffic in the charts for this, I hope. Maybe not. But what I can definitely see is, yes, I see some traffic. I see that I have one event hub. So this is the source event hub. That's why it's called source. And it's been getting some traffic. What Mirrormaker does, I told you, it's just copying data from one place to another. So I'm going to go look at the destination event hub. And what I should see here is another event hub with the same name as the source, and it too getting some traffic. So yes, this is working. That is a successful demo, actually. But what's interesting here is, so what did I just do? I just made geo-data replication between any regions that you choose without running a server. So is this serverless? Does anyone think this is not serverless? Like, yeah, I know you do. Enough out of you. So does anyone else think this is not serverless? Like, I could see CPU charts, I could see memory charts. I have all these sophisticated streams and things that'll auto-scale, but there are no servers here to manage. So this is pretty successfully serverless, I think. I think back to the time when I was doing like programming work for trading systems. And so one of the things people will say about ACI is that, well, it's not an orchestrator, it's not going to scale like Kubernetes. No, it's not. But entire trading firms ran on less computing power than what that one container instance has. So when I was working in the trading industry. So one container, up to 4 cores in it, you can run a lot of stuff in there. So when you have not super scale stuff to do, it's a good answer. As a product owner for some pretty big products in Azure, I can say that the majority of our customers are not people doing 1 million transactions a second. So like that, I know we like to brag about that and talk about that, but that's the minority of customers. Most people don't even do the 1,000 messages a second or 1 megabyte per second that you can do on Event Hubs as the cheapest thing we sell. They just do, how many things do you sell per second, or how much telemetry, how many users use your things per second. So I want to kind of focus us a little bit in our serverless talk here about how do we solve most of your problems. Okay, fine, I hope your business is successful enough that you need to do 1 million things a second at some point, but you probably don't in the beginning. So we have stuff that you can start with very easily to do that. So the key question when you're looking at serverless here, and kind of my point for this part of the talk, is that the messaging aspect and the compute aspect, so serverless and messaging, are really inseparable. And you have to choose what you're trying to do and choose the right tool to do it. So if you were trying to build a stream processor, functions may or may not work for you. It might, but it might not. If you're trying to just process like tasks, if you're trying to do a task processor rather than a stream processor, maybe Event Hubs isn't the right choice for you. It's tempting to say always do these things, but it's a little bit easy, too easy to do that. Trivialize it into something it's not. Let's go back to that moving average processor. It would be much more interesting, other than writing out to the council that a moving average cross has happened, to actually do something rather than stare at a screen all day. If you've ever wondered, if you've seen like pictures of traders or currency traders and stuff, and they're just sitting there looking at 10 or 20 screens all day, they're literally just waiting to be automated. So that's been a big change in that industry too. So let's look at eventing. So Event Grid is a service that we released last year. We GA'd a year ago of my day talking at this conference, actually. That was how important Finland is to me, that we GA'd on that day for IglooConf. No one thinks that's funny. Great. So has anyone tried it in the last year? Is anyone using Event Grid? Good, couple people, cool. So we built it as another type of messaging system, because we've already talked about messages, and message really is kind of focused on the intent of the sender. I want to send you this, so I'm sending a message. Now it's going through some middleware and shit and whatever, but like, I have an intention as the sender. A stream is a different construct. It's a construct that's focused on more than one message, on more than one piece of information. And then you get events. So kind of you get the third messaging construct in here. And an event is really a notification. Rather than saying, I want to tell you about this, what you're saying is, you just have interest in certain things that I might say, and not all of them, and you might want to route them somewhere else. So Grid kind of fits in this place where you have events on one side. You could almost think about it as a type of message, and then you want to process them with other stuff. So what's it for? The 3 focuses for this are serverless applications, which is kind of the main focus of this talk, for ops and automation stuff, which is increasingly becoming kind of serverless when you start thinking about how you could run a container with a shell script in it, which is just what I showed you. So run some compute with a shell script when an event happens. You're kind of making the ops world be serverless as well. And then for third-party integrations. And third-party integrations is actually what it's most used for right now, and that's kind of interesting. We have some stuff there that's cool that I'll show you in a second. So why did we build it? Why did we build Event Grid anyway? We already have 3 messaging systems. Why do we need a 4th? The first is because you should never have even numbers of things. You should always have an odd number. And you should have an odd number greater than 3. So we needed to get to like 5. And with storage queues, I guess we do have 5. So we're in the right place now. So this is how eventing looks on another cloud platform that I will not name. Look carefully and you can see which one it is. As you see in this is awesome. There are many different ways to see what an event source is. And this is actually a sample from this cloud provider, so it's kind of funny. We wanted to avoid that. During the last year, I accidentally showed this to the person who built that platform. I didn't know that he works somewhere else now, and he saw it, and he just gave me a little giggle. It's kind of funny. So there are 5 concepts here that we'll talk to you about real quickly, just to kind of conceptually get what's different about Event Grid than like queues or streams. An event is just something that's happened. So an event happens. A publisher is where that event took place. It's storage. I created a file in storage. So the event was the creation of the file. The place it took place was in storage. So that's the publisher. The topic is where the publisher is going to send that event. So storage is going to send these events somewhere. And the subscription is how you express your intent or your interest in a specific event. And finally, the event handler is the component you've chosen that's going to react to that event, whether it's a function, a logic app, a relay, or hybrid connection, or something else. So those 5 things. An event's very simple. An event is not meant to carry too much data in it. It's meant to be lightweight. And in this case, it's routable on 3 primary things: the topic, the subject, and the event type. So event types are domain qualified. You can see that this is a Microsoft storage blob created event. And all events have a data field that's JSON that you can stuff whatever you want in. But what's in that data field is, in Azure at least, driven by what type of event it was. So this is the data for a Microsoft storage blob created event. We've added advanced filters. They're in preview now. We added this in December so that now you can, rather than doing topic, which if in that previous example, the topic's the ARM ID of my storage account, so resource manager ID. The subject is the path within that storage account to the file that was created, and then the event type's pretty self-explanatory. Rather than just letting you route on that, which we like that as a service provider because it's a prefix match. It means that our lookup on the total universe of subscriptions has a runtime of big O log of n. It means it can be very fast, even if we have a lot of them and it's not very expensive. So that's good for us. But you as a user, it's maybe not so good for you because you can't fit all of the world into one path-based model. If you could, everyone would do things in files. Because that would be pretty easy. So what we did, we actually added different operators. So you can see a list of operators we have, and you can now do advanced filters. And so those filters, you pick an operator like number, greater than, or equal. You pick a key. The key means somewhere in that message. In this case, you can see the key is data.key1. And then you pick a value. So you're saying this is how you construct a query into that data payload. So you can have up to 10 of them on a single subscription. The operators are this list on the left. So greater than, less than, whatever. These are number operators, numerical operators. These are string operators. And then the keys are this. So there are keys for topic. You can now do subject contains rather than just a prefix match on the subject. And then you can actually crack the data piece open and do things within data. Like on the storage example, if I go back to that, I could now do data.requestID or data.blobtype or data.url. So that makes your life a little bit easier there. The next thing is event domains. So this is out now. It's in preview. Try it out. It's cool. It will make Grid much more useful for you as a subscriber to Grid. The next piece is event domains, and I swore we would not use this name, but marketing ended up making us use this name. So we couldn't find anything better. Event domains give you the ability to have your services published the way Azure does. In Azure, when the storage service is publishing events, it doesn't publish one event for every single storage event that's happening, for every single write that's happening in storage. It publishes big blocks of them with lots of customers' events in that big block. It makes it way more efficient for the storage service, and also having to dispatch to different topics would have that's what Grid does, so it would have defeated the point. The idea here is rather than using custom topics, which you have been able to use since we shipped Grid, we now give you a top-level domain, and you can control topic structures, and you can authenticate people to subsets of them. So today in Grid and Azure, it fits really well because there's Active Directory authentication with everything. So if you try to go listen to a storage account, the Azure system actually RBAC checks, so role-based access control, checks your credentials and your ability to listen to that storage account at runtime. Well, how do you do that when it's your service? You're providing a service to other customers in other parts of your company. It's not an Azure resource, so we can't check that way, and you still want RBAC. So it actually still works through AAD, but now you just assign user identities or service principal identities, accesses to paths, meaning topics in your service. So you get a top-level domain, you publish all your stuff to the top-level domain, and we will just shred and dispatch all the messages in there. How that means, how it looks like to you is that you can batch your events up. I can have a topic. I can say this event is for topic foo. I can say this one is for topic bar. And I can put whatever data I want in the payloads. And now when someone wants to come and listen to those, it's just like subscribing to a storage. It's just like subscribing to events from Cosmos. Oh, that's right. There aren't any. Sorry. It's just like your experience in Azure is. So that's our intent, is to give you that same type of experience. What's cool about this, though, is what's different about Grid from like queues and things like that, is that this is consumer focused. This is, and I mean consumer is in the consumer of the message, not like home entertainment type stuff. So this is really focused on consumers being able to listen to events in your applications or in your organization without having to come and ask you which they can listen to. While at the same time, you being able to lock down what sort of things are they able to listen to. So in Grid with the domain, if you have the right permissions, you could say the topic I'm interested in is everything. So you can tap into the stream of absolutely everything. You're probably not that interested in it. You know, very few people are interested in everything. Whereas you can say, I want to make sure that Chris can't tap into everything. He can only tap into the Cosmos topic. So let's do a quick recap on what we've covered. I know it's getting close to done. So that's that messages are center focused. That's kind of been my message today. That streams are different from messages because it's a set. So streams are a set. They're not even a set, they're really a stream, because a stream has no end. So it can keep streaming forever, which means it's actually, technically, that's called co-data, not data, because it can go forever. Data is finite. Events are very subscriber-driven rather than publisher-driven. And so this is kind of the third construct you need to be able to take anything you want to write and think about how would this work in a serverless style. Is you need these three messaging constructs. And then you need, there's a fourth one you need, and actually, fortunately, several people have talked about it today, although I missed your session, Brady, on this, is you need sockets. Sometimes you want things over a socket rather than a message. So you have two choices for that in Azure. SignalR, which is really good for kind of last mile and broad connectivity, and things like hybrid connections, which let you pipe whatever you want over a socket. I didn't talk about hybrid connections today because I didn't think I had enough time, and I thought Friday afternoon is no time to be talking about WebSockets and networking. But it's a way that you can do things like RDP or SSH, or even send video to devices that don't have inbound connectivity to them. So it's cool thing. And then we talked a little bit about functions. So simple code without servers, and about ACI, so containers without IaaS. So like these are the ingredients that you can start pulling from to say, yes, I want to build this type of application. I don't want servers, I want it to be serverless, so I'm going to pick this type of compute, and it's going to need this type of messaging to support it. So our work, when we get back to Redmond, and some of it's already going on, is how do we make this simpler? So today you still have to make these choices. I'm sorry, but you do. We are trying to make it so easy that you fall into the pit of success and that you always pick the right tool. So in Event Hubs, for instance, we're going to be adding that Mirrormaker thing into the portal, so you can just click, yes, I want to copy my data from here to there, and always have this running. So that's kind of the new stuff we're thinking about, is how can we make this easier for you? If you are interested in technical analysis, you should watch this movie, Pi. Has anyone seen this? It's from the 90s. Yeah, this movie is crazy. Don't watch it with your kids. It's good, though. Please remember to fill out the survey. Yes. And thank you for having me here. I'm happy to take any questions. We have just under 10 minutes left to do questions. And yeah, thank you again for having me back. I love Finland. Love you all. Oh, people are less interested in my dog than the URL, huh? Yeah. It was a different dog last year for anyone who was here. Yes.
In your ACI sample that you claim is serverless, who patches OpenSSL?
Oh, there's an even better question for that. So for Mirrormaker, ACI will update underneath. When I look at my load generator, that finishes when it's done. So anytime it runs is when it's instantiated. So I agree, some things you don't want to run forever in ACI. I actually don't think ACI is necessarily the place you want to run things forever. If you know you want to run something forever, and especially if it's not a trivial workload, an orchestrator like AKS is a good place to do that. But if you just want to say run this code until it's done, ACI is perfect, because unless you write it in code that you really do plan to run for months, it won't matter about patching OpenSSL, because the next time you instantiate a container, Azure will have already updated that. I bet you didn't see that one coming. Although one of those containers is running forever, so yes. Yes? When is managed Kafka coming to Azure? Yes, that is a good question. Well, in a way, it's already there, right? I mean, there's that option on Event Hubs. I just used Mirrormaker. So that is our strategy. Just like with Cosmos, how we're giving you different protocols on a single service. We have now, actually, we stole that idea from Cosmos. We put the Event Hubs, the Kafka protocol on Event Hubs to do the same thing. There are a few reasons why we did this. The first is actually that just over 5 years ago, when the engineering team started Event Hubs, we actually looked at hosting Kafka. There were some things then Kafka was not nearly as complete as it is today, so it had a lot of problems. But even beyond those problems, Kafka has some big problems today in that it's not designed to be a multi-tenant service, which is okay for some people, but as a cloud provider, it's not so okay for us. So hosting Kafka on your behalf means we need at least 3 and probably 5, remember like odd numbers greater than 3, machines to make it durable. That's problematic because a lot of people don't need 5 machines worth of telemetry. You know, most Event Hubs users are sending gigabytes a day maybe, not petabytes, not terabytes. So we're not really planning to make a managed Kafka service. We have 2 things available that can help. One is HD Insight Kafka, which is a compute platform with Kafka on top of it that you can still SSH into and you can fiddle with and have full control over. And then the other is Event Hubs with its Kafka support, protocol support. And the Event Hubs with Kafka protocol support thing is pretty cool because there's a lot of stuff in there that's done for you. So like all the TLS stuff is done for you, all the encryption and security is done for you, and you can run it at a very large scale or very small scale and pay for what you're using, which I won't say that pay-as-you-go is serverless, but I would certainly say pay for what you're using is serverless. And kind of the problem with running a Kafka cluster tends to be that the starting price is quite high. I mean, as someone who has a lot of shares in Microsoft, I'd be very happy if you spun 5 VMs every time you want one stream of data, but I don't think it's hard to I think it's hard to justify that. Kafka Streams. Yes, the question is about Kafka Streams. Kafka Streams is a protocol extension, or it's a feature extension on top of Kafka. There are 3 big extensions that are popular. One is Mirrormaker, one is Connect, and one is Streams. Connect is available now. So you can use Kafka Connect, which Kafka Connect's a tool for doing like integration. It's actually pretty cool. You can point it at a source, like a MySQL database, and then write the records to a sink, like a Mongo database or like a blob file. So we did Connect first, just because more customers asked about Connect. Streams is coming next. But to be quite frank, is this part still on live video or?
I can say closing words now and then it's not?
No, I mean, it's okay. To be quite frank, the onus behind doing streams was really because of KSQL, and Confluent changed their licensing of KSQL, so cloud providers can no longer host KSQL. So we can't make a managed service out of that. Amazon can't. And so now there doesn't seem to be as much demand for streams, but we will do it in the second half of this year. Good question, though. Thank you. If you want streams, I want to talk to you. Don't go away.
Anyone else? Anything other on messaging?
So the question is about at what throughput would you choose which of the messaging services? And the big thing I would throw back is that I would never start from throughput. I would start from somewhere else. I was in Copenhagen last year and used this analogy I'm about to say for the first time. Second time, I first used it with an executive at Microsoft, and I don't know if he thought it was as funny as I did. And it's like having a spoon, a fork, and a knife. And you're basically saying which of these is the best. Well, it depends what you're eating. So, and it doesn't, a spoon is good for soup. It doesn't matter if it's a small bowl of soup or a big bowl of soup. The spoon is the right tool for that. Eating soup with a knife is very hard. So I wouldn't pick services based on the size of what you're doing. If we're doing our jobs right in Azure, everything should be able to scale. And Service Bus, if you go into like premium Service Bus, you can do tens of thousands of messages a second, which is the most people need. And if you really need more, we can probably work with you. The temptation for people is to start with scale. I would always start with what you're doing. So is the thing you're working with a stream, or is the thing you're working with individual messages, or is it something else? Are they just events? And then I would work back to what's the right messaging service. Like the big thing there is client-side or server-side cursor, and degree of parallelism you're looking for. Does that answer your question at all? Yeah. I mean, we love to have people hit the limits. So if you do find usage stuff where something in Azure is not scaling the way you expect, we want to work with you to make it. So the question is, does streaming technologies or eventing technologies introduce duplications? This is a really great question. I wish I had put this other slide up. I probably still can, because the implication you're making is like if you don't want duplicates and all these other things, Service Bus exists as a service in a place where people are used to enterprise messaging, which is things like IBM MQ and TIBCO EMS, because you get all of these features in the broker that do work on your behalf. Like duplicate detection is one of them. The ability to do once and only once processing is something that really only Service Bus can give you. None of the other messaging services in Azure can, and Event Hubs certainly can't. It can give you at least once, but it can't give you once and only once. And that really comes back to it being a client-side cursor. So if it's a client-side cursor, that means that the onus is on you, the consumer, to know what you have read, to know what you've already processed. Because if you connect back up to that partition and you're seeing duplicate data, you're seeing data that you already read yesterday or something, you need to be aware of that. So the service doesn't help you out. So that's a great point of why I would think about what you need first, and then like your usage needs are, and then find the service that matches. And if you need to avoid duplicates, do not use Grid or Event Hubs if you can, because they're really made for, like Grid in particular it's cloud native. It's made for serverless. It's made for the cloud. But that means that, and it's really scalable. But there are characteristics that the cloud demands of everyone now. So eventual consistency is a basic characteristic that all distributed modern stuff requires. And if you're doing greenfield development, you can probably build it in. If you're not doing greenfield development, it can be hard to add on to an existing system. Thank you. Yes? The question is about plans for increasing the data retention time or size on Event Hubs. Well, let me give you a surprise. This will be announced in like a week or two. We have already done it. There is really not a hard limit on it anymore, but you pay per gigabyte after those first 84 gigabytes. So you buy an Event Hub throughput unit, it's 1 megabyte per second. That means in a day you could have 84 gigabytes. And now we will let you, up until, like right now today in the portal, you can make that 7 days, but now you'll be able to make it like 30 or 60 or whatever you want. Yeah. And you pay, if you're not using a lot of data, which most people aren't, you don't pay at all. You just get more time for free. But if you're filling the throughput unit, then you get, you pay per gigabyte over. Thank you.
Are you getting shit for announcing something online right now?
If I am, I'm not there to hear it.
Awesome.
And it's Friday afternoon, so I'm not going to be around to hear it.
Don't leave Finland ever, right?
There's many reasons not to, so maybe I won't be able to get back into the US. Our government's shut down, if you're not aware, so. All right. Thank you very much.
All right. Thank you, Dan.